Hello, everybody, and welcome to today's TM Forum webinar, Beyond Monitoring, OSS Best Practices from Leading Service Providers. My name is Hugo Vaughan, the Chief Architect of the TM Forum, and I will be moderating today's webcast. First of all, I'd like to thank Objective Systems Integrators, or OSI, for sponsoring today's event. Before I introduce our speakers and get into the presentation, I'd like to briefly go over a few housekeeping tips. If you would like a larger view of the slides, please click the green button located at the top of the slide area window. There will be time for questions after the formal presentation. To ask a question, please type it into the Q&A window on the left side of your screen. The presenters will respond to as many questions as time allows. We have a lot of material to cover today, so quickly I'd like to introduce our speakers. Presenting from OSI are Roger Hosier, the Chief Technologies Officer, and Andrew Lim, the Senior Project Manager. Presenting from Maxis Broadband is Tiagi Seladurai, the Head of OSS. At this time, I will turn over to Roger Hosier to start the presentation and go over today's agenda. Roger, over to you.
Thank you, Hugo. My name is Roger Hosier. I am Chief Technology Officer at OSI. I'd like to thank and welcome everybody for joining us today. OSI is excited to be able to sponsor this event and share the experiences and insights from a customer in one of the fastest growing markets in the world. As you can see from the agenda, we have split the presentation into two areas of focus, and we should have some time for Q&A at the end of the presentation. I will not be taking too much time away from what's going to come and what you came to hear about, but I do want to set the stage before turning it over to the speakers. To frame the presentation, I wanted to share some of the concerns we at OSI hear repeated as we engage with service providers throughout the world. I'm sure that you all have either heard or have to deal with these on your own in your own environments, and of course you have many other aspects of your networks and managing your services and customers that could be listed, but we have to focus. We only have an hour today. So we picked three of the top areas that we hear about, and we'll focus on those in the presentation. The first item that we want to talk about raises the issue about networks growing in size and complexity. The volume of information in the form of alarms, events, and measurements exploding. We have to find better mechanisms to allow us to prioritize the data flooding into our management systems. The good news is that if we can do this effectively, we can become effective at management, which means that we can be better to control cost and introduce effective automation strategies. The second item that we want to focus on for managing your networks effectively is to allow you to understand how network elements are related to each other and the products, services, and customers that they support. From this understanding, you can drive to understand the impacts on your customers and respond more effectively to the volume of data that you have coming into the management systems that you're using. And then the final item deals with what we're seemingly is an age-old issue of integration. I've been in the industry for a long time, and we still deal with the disparate applications and the need to get them talking to one another effectively so that we can reach our goals of really managing the network and understanding what's happening, who it's impacting, how it's impacting them, and what to do about it, and what's the most important thing to do about it. We hope to touch on each of these issues to some extent in the presentation today, but we understand that we cannot go deeply into all aspects of these issues in just an hour. So please ask questions and follow up after the webinar if you would like to explore these or other aspects of your needs further. Today we're going to be hearing from Maxis, a provider in Malaysia, but we see the same challenges from others throughout the APAC region and globally. As the slide represents, mobile voice business continues to be under pricing pressures, and the growth rate and subscriber adoption has to slow as the penetration of voice services becomes mature. There are just only a limited number of people for you to deal with. But the growth in data versus voice is remarkable, as technology, infrastructure, and user sophistication have come together to form an almost perfect storm of demand. We don't discuss this today, but as many of you are probably aware, the number of connected devices and machine-to-machine connections is estimated to be a much greater growth rate than the number of mobile voice connections. The demands of these devices and the applications will just continue to swing the provider's traffic further from voice to data. Infrastructure initiatives like LTE and LTE Advanced will help keep providers in step with usage demand, at least we all hope so. But how do you deal with the management of this new and growing infrastructure? The forces all lead us here to what Mr. Das had to say about Malaysia and Maxis's opportunities within the country and the region. What did he say? Malaysia stands at the cusp of the telecom industry's transition from voice to data. The demand for data and broadband have gathered considerable momentum, and as a company we are pleased to be at the leading edge of this transformation. He certainly has hit the nail on the head for a lot of the providers that we talk with. The market has definitely swung to data, and you have to be ready to deal with it, or you're going to lose your position as a voice carrier. But there is good news. If you're successful at managing the shift from the predominantly voice carrier to a data-centric organization, there can be rewards for your efforts. As you can see, Maxis is making the most out of its opportunities as embracing the data revolution and doing it successfully. If you look at the slide, you'll see that the earnings and the revenue from non-voice is remarkable. 7.5 million of their customers are active mobile internet users. I'm sure you and your industry see the same usage. So how are you going to deal with it? That's what we're going to talk about today. With that, I'd like to introduce the first presenter for today. Please join me in welcoming Mr. Thiagi Saladura from Maxis. Welcome, Thiagi.
Thanks, Roger. Thanks, Roger. Hello, everyone. Let me start off with a brief introduction about myself. I started my career in Maxis Malaysia 17 years back as a software engineer in TQA department. After 3 years, I joined OSS department, and with the subsequent 14 years experience in OSS, I'm currently heading the OSS department. In OSS, we oversee more than 20 state-of-the-art OSS applications covering the service fulfillment, service assurance, customer experience, workforce management, and also the other OSS domains. I was also the project manager in charge of implementing the Maxis port management back in year 2007, and also a subsequent announcement to cater for the Maxis business need. So in summary, I have around 17 years experience in telecommunication field with vast knowledge in OSS domain. Okay, let me quickly provide an overview about Maxis organization, an organization that I'm part of for the last 17 years. I'm part of Maxis Malaysia, which is part of Maxis Malaysia, who is also under the Maxis Group, or Maxis Communication Berhad. And Maxis Communication Berhad, or Maxis Group, has other stakes in the telco provider in Asia Pac. We have 74% share in Aircel and 15% share in Axis Indonesia. Our parent company, Uzat Tegas, has a 45% share in Sri Lanka Telecom, who in turn has 100% control over Sri Lanka. A quick overview about Maxis Malaysia profile in terms of the financial statement and also the company performance. We started our operation in 1995 and became the mobile market leader in year 2001. For information, we are still the mobile market leader in India after 12 years. We are one of the top 10 companies in nation share market when we went public in year 2010. Our subscriber currently stands at 14 million with the market revenue share of 39%. And out of 14 million, we have close to 12.7 million revenue generating subscribers. Our revenue as of 2011 stands close to $2.85 billion with an EBITDA margin of 50.3%. We have close to 3,450 employees located in various parts of Malaysia, managing the network and also the organization. Maxi's vision is to provide the best customer experience lifetime, and our strategy is to transform ourselves from the main mobile leader or player in the market into an integrated telco service provider. And we achieve this by offering a wide and ranging range of products to cater for the future needs of the Malaysian personal, SME, home, and also the enterprise market. As part of the telco service provider, we offer a various range of services to the consumer and also the enterprise market. And the services we offer mainly cater or focuses on the 5 key areas, which is the mobility, home, broadband, international gateway, and also the enterprise. To get more details about Maxis, you can always access our website, www.maxis.com.my. Let me briefly introduce about the Maxis fault management system. Currently, we are using OSI NetExpert as our fault management system. The system was implemented back in year 2007. Of course, we are continuing evolving the application to cater for a Maxis need. We have done a lot of wonderful initiatives via the fault management system. Our vision back in 2007 on fault management is not only to monitor and detect alarm, but also to implement an integrated network management system. The integrated network management system is achieved by integrating our fault management system to various third-party tools such as the performance management system, trouble ticket, inventory, work permit, element managers, and so on. So with this sort of integration in place, the end user will be able to manage and troubleshoot the network alarms much effectively. And with the enriched data in the system and also the event correlation capability, we are able to isolate the fault much faster, which leads to operational efficiency and also a shorter MTTR. Currently, we are monitoring close to 90% of our network via the INMS application. It is also mandatory that we need to integrate all the new network elements into the INMS application before we can bring it into service. Okay, now let's zoom into the focus of our presentation today, Maxis best practices. As I highlighted earlier, we have implemented a lot of initiatives, but today's focus will be mainly on the brand side fault management. One of the key challenges that we face in this area which led to this initiative or investment. The first one is we need to manage a high volume of alarms from 13,000 RAN elements across the network. Currently, I believe we are managing more than 200,000 alarms on a daily basis for these RAN elements. Secondly, we need to manage environmental alarm, which contributes to 60% of the network docket more effectively, more efficiently. And thirdly, we also need to start preventing site intrusion and site vandalism, which is quite prevalent in Malaysia to prevent site service interruption and also the revenue leakage. And what are the initiatives that we implemented to overcome the gaps and also the challenges? Firstly, we implemented the alarm and the docket prioritization. This enables the end user to prioritize which problem they need to tackle first. And secondly, we implemented the auto detection and docket escalation for the environmental alarm. I'll go through the details shortly. Let's look at the first use case, which is the alarm and docket prioritization. And the solution we used to achieve the initiative is quite simple. What we did is we included 3 additional information fields. The 3 fields that we use is the site priority, which indicates whether the site is a VVIP site, urban site, or a rural site. And the second field that we use is a site classification to indicate whether the site is a BSC site, upsite, trunk site, and also the end site. This will enable the end users to identify which site is having a high density traffic and also revenue. The third initiative or the third field that we included was the alarm quadrant mapping for each of the RAN alarms. So this alarm quadrant is categorized into 4 different quadrants, quadrant 1 to quadrant 4, which identify whether the alarm is a service impacting, non-service impacting, or an environmental or a performance alarms. So with this sort of information available for the end users, they will be able to prioritize which high revenue site they need to tackle first in order to overcome the problem. Now let's look at the second case study, which is the auto detection and also docket escalation for the environmental alarm, which covers both intrusion and also power alarms. Okay, I'll start off with what is site environmental alarm about the site? There's actually 8 auto alarms, which is under the environmental alarm, which can be categorized into 3 different categories, which is the intrusion alarm, power alarm, and also the tower light alarm. For information, for single power failure, the system will generate few auto alarms, auto 2 to auto 7. And our focus today will be on the intrusion alarm and also the power alarm. Let me start off with a brief summary overview of the intrusion alarm initiative. The objective is, of course, to automatically and immediately detect the intrusion alarm to prevent site intrusion and also site vandalism, which will lead to revenue leakage. We have close to 1,800 door alarm or auto alarm that's being generated on a daily basis. It's quite cumbersome or tedious for the controllers to manually validate this 1,800 alarm on daily basis, whether it is a maintenance, access, or a site intrusion. The intrusion alarm solution actually encompasses of a few key areas. First is we need to integrate our fault management system to the work permit and also the IVR module. The site engineers or the contractors need to log into the IVR module before they can get the clearance to enter the site. So it's one of the key applications that we use to validate whether the site is site intrusion. The INMS application will then validate the door open alarm or the Opto 1 alarm from the element manager against these 2 applications to identify whether it's a maintenance, access, or a suspect intrusion. And the below alarm panel here shows the description of the alarms, the intrusion alarms that's being displayed to the end users. Now let's take a look at the intrusion alarm processing logic. Whenever an Opto 1 alarm is received from the element manager, the INMS application will cross-check that against the IVR application to see whether there's any planned event or not. If there is a planned event, then the alarm will be tagged as no intrusion and we will close the cycle. If there's no record found in the IVR system, then the alarm will check whether it's a false, system will check whether it's a false alarm or not. The reason why we need to check whether it's a false alarm is because some of the sites has a door sensor failure which will generate intermittent Opto 1 alarms. So we can discard these alarms. If there's no false alarm, then the system finally will check against the work permit and the docket system. And if there is no record available in these 2 applications, then the system will stamp the alarm as suspect intrusion with critical severity for the relevant parties to take the necessary action, such as mobilizing the resources to the site to prevent intrusion and so on. So in terms of benefit, it definitely improves the operational efficiency because right now we can eliminate all the manual tasks of validating the Opto alarm whether it's a site intrusion or not. We can prevent unnecessary truck roll because the system will now only raise docket for genuine site intrusion. By immediately detecting the site intrusion alarm, we can also prevent site vandalism and service interruption, which also leads to reduction in the revenue leakage. Now let's take a look at the second initiative, the power alarm initiative. In terms of objective, it is similar to intrusion alarm. We would like to automatically detect the power alarm and also the docket escalation. Currently, we have close to 2.5% of our site, RAN site, generating power alarms on a daily basis. And as I mentioned earlier, for a single power failure, the system will generate multiple power alarms. And it's quite tedious or labor intensive for the controllers to manually track this power alarm for a particular or a single power failure. Okay, next, let's take a look at the behavior of the power alarms. Whenever there's a power failure, Opto 3 alarm will be generated. Power failure can be due to a power trip or no incoming supply from the power supply provider. Subsequently, an Opto 6 alarm will be generated indicating the site is already running on battery. Since there's no power in the site, the icon will malfunction and will generate an Opto 2 alarm which indicates over temperature. Finally, an Opto 5 alarm will be generated which indicates the battery is low and the site is going to go down shortly. The power alarm solution encompasses of a few key areas. First is defect prioritization, as I highlighted earlier. It's very important the PLOPs or the controllers need to isolate and also tackle the high revenue generating sites because, as I mentioned, we have close to 2.5% of the brand elements generating power alarm on a daily basis. Secondly, we do a simple opto correlation. Basically, we correlate the multiple alarm from a single failure into a single correlated alarm for easy detection and also easy management and monitoring of the alarm and docket escalation. Thirdly, we set appropriate sleeping time to the basic opto alarm for docket triggering. So this is quite essential to ensure that docket is triggered at the appropriate time and not sooner or later. I'll go through the details shortly. Now let's take a look at the step one, power alarm correlation. As I mentioned earlier, when there's a single failure, the system or the site will generate multiple power alarms. So what the system will do is it will correlate and consolidate all these basic opto alarms, opto 2 and opto 7, into a single correlated alarm called C-opto. C-opto will act as the primary alarm and also the only alarm that will trigger docket. So with this implementation in place, the end user need to only manage one alarm, which is C-opto alarms. And if they would like to see the detail of the basic opto alarm, they can drill down from this C-opto alarm. The second step that we took is the configuring the sleep time for the basic opto alarm. So opto 3, opto 6, and so on is considered basic opto alarms. So when we configured the sleep time for all these alarms, the system will only generate docket if the sleep time for this basic opto alarm expires. And of course, this is based on the logic that we have built and also the C-opto behavior. In the next few slides, I'm going to explain to you how the docket is being triggered based on the sleep time and also the C-opto behavior. I'm also going to use the example of the sleep time for opto 3 as 180 minutes, opto 6 as 30 minutes, opto 2 as 50 minutes, and opto 5 as 5 minutes. Okay, there are three C-opto behaviors that we need to take into consideration for auto docket triggering. The first behavior is C-opto takes the shortest waiting period from the basic, the most critical opto alarm. If you look at the diagram below, at T plus 0 minutes, an opto 3 alarm is being generated. Subsequently, a C-opto alarm will be generated, which will correlate the opto 3 alarm. Now, the C-opto sleep time will take the opto 3 waiting period, which is 180 minutes. After 15 minutes, an opto 6 alarm is being generated. So the C-opto alarm will now be upgraded to correlate both opto 3 and opto 6 alarm. At this point of time, the C-opto will now validate the sleeping time or the waiting period between the opto 3 and opto 6 alarm. Here, the opto 3 waiting period is around 165 minutes, whereas opto 6 waiting time is 30 minutes. So the C-opto time will change to 30 minutes based on the shortest waiting period of the outstanding alarm. Subsequently, an opto 5 alarm is generated with a waiting period of 5 minutes. Here, the C-opto alarm will correlate and consolidate opto 3, opto 6, and opto 5 alarm. And at the same point, at this point of time, it will then validate the shortest waiting period between opto 6 and opto 5 and choose 5 minutes as its sleep time. So that's how the first behavior, C-opto behavior, works. The second one is the second behavior is if any basic opto alarm clears, the C-opto sleep time adjusts the next shortest occurring outstanding opto alarm sleep time. If you look at the example below, at T plus 20 minutes, an opto 2 is generated, and the C-opto sleep time will be 15 minutes based on the opto 2 alarm. After 5 minutes, for example 6, the opto 2 alarm is cleared, and at this point of time, the C-opto will discard opto 2 from its tracking, and now will validate the sleeping period or the waiting period between the outstanding opto 3 and opto 6 alarm. Here, the opto 6 waiting period will be close to 20 minutes, and opto 3 will be 155 minutes. So C-opto will take the next shortest occurring basic opto alarm sleep time, which is 20 minutes. The third C-opto behavior is pretty straightforward. If all the basic opto or C-opto alarms cleared before they reach the wake-up time, then there will be no docket triggered. So the next slide shows the sleep time that we have configured for critical sites and also the less critical sites. And the sleep time was actually derived based on our historical analysis on the historical power alarm data. So if you look for the less critical sites, the sleep time for opto 3 is around 180 minutes. This is mainly to cater for power alarm or power failure due to no incoming supply from the power supply provider. Based on our analysis, it usually takes around 3 hours for the power supply to restore the power. Next, let's take a look at the power alarm auto docket logic. It's similar to the intrusion alarm. Whenever an opto 2 or C-opto or opto 2 to opto 7 alarm is received, it will first check against the IVS system to see whether there's any planned event. And if there's a planned event, then it will check whether there's any docket available. If there's a docket available, it will append to the docket, or otherwise it will create a new docket. If there's no planned event available, then the sleep time logic will kick in, and after it meets the sleep time criteria, the system will then check whether there's any docket available and take the subsequent or the following action accordingly. The next slide shows the snapshot. The next slide shows the benefit of the power alarm initiative. There's definitely improvement in terms of the operational efficiency. We are able to automatically detect and escalate docket, and we can eliminate all the manual process of end users to manually manage and track the power alarms. We can also optimize docket escalation because we don't raise any unnecessary dockets based on the sleep time logic that we're building. Some of the alarms we allow it to clear by itself, especially the opto 3. And with this auto detection and docket escalation in place, now we are able to minimize missing alarms, and at the same time we are able to reduce the site outages, which also lead to reduction in the revenue leakage. The next slide shows the snapshot of the actual time taken for us to trigger auto docket for the critical site and also the end site. As I highlighted earlier, for critical site, we take around 7 to 9 minutes to raise a docket, and for end site, it could go up to 3 hours based on the opto 3 alarms. Besides the benefit I just highlighted, we also see significant reduction in the opto 3 alarm. We saw 50% reduction in opto 3 alarm, which in turn lead to 7.5 reduction in the total nationwide or network dockets. We did a post-analysis after 6 months implementing the solution, and we noticed the number of open dockets has gone down to 38%. That's a significant reduction, and one of the reasons we noticed is because we are able to manage the power alarm more effectively, and we also prevent site outages. So with this initiative, we are now able to see increase in network availability and also the customer satisfaction. So that concludes my presentation on the Maxis as practice. However, I shared with you